Knox Game Design. April 2021. Image file formats.
Welcome everyone to Knox Game Design for April 2021. My name is Levi Smith. This month I'm going to be talking about image file formats. So originally I didn't think this was going to be a very in-depth programming type talk or presentation, but I found a way to actually make it a little bit, I don't know, more interesting to me than just talking about what the different file formats are. But yeah, you can use like many different file formats for games, for importing textures and sprites and things like that. So I'm going to be talking about the differences between those and also how at least one of those files is generated. So why are file formats important? So first thing you want to look at is the file size when you're choosing a file format for a game that you're developing, file size and compression. So some files can be very big, and if space is important, if you want to make a game and have it relatively small for distribution, that may be one of the considerations you want to consider. And to reduce file size, there's various many types of compression that you can use. Another one is color depth. If you look at a lot of the old games that don't have very many colors, maybe 256 colors or 16 or something like that, all the way up to like 24-bit true color. So it depends on what type of aesthetic you're going for. Are you going for a simple color theme where you can use just a reduced palette, or do you need full color for your game? Another thing that you want to consider is transparency. If you're doing a sprite-based game where you don't have the entire image with pixel data, you want some, when you put that pixel on the screen, you want some of the pixels to remain transparent. That will also be a consideration you need to make. And also, finally, array versus array is in raster graphics versus vector graphics. You want to have a game that kind of looks like a Flash game that uses vector graphics, where as you zoom in and zoom out, it retains that crisp view, or will an array pixel sprite-based game be sufficient? So I was talking about a little bit earlier about the image quality. What they call is lossless. There's no reduction in image quality. It's basically just raw image data. Sometimes you want to store the raw image data in long-term storage, so that might be one reason you want to store it in a lossless format. Then there's opposite of lossless. So lossless means you're not losing any of the data at all in your image. The opposite of that is lossy, which means there's compression that makes the image lose some of its quality. There might be some blurring and things like that in a lossy image. So that's one thing you'll consider, is the image quality and lossless. Also is compression. So compression isn't necessarily lossless or lossy. You can have a lossless image that also has compression. So compression is just underneath the surface, behind in the image data. Is there a transformation of the pixel data into a way that it makes more efficient to transfer, a smaller file size? And finally, as I mentioned earlier, transparency. So I have some of the image file formats listed on there. I'll be talking about each one of these file formats a little bit more in depth. But basically, if you're going for a lossless image, you want the exact quality with no compression and no transparency. You might want something like a BMP. That was the Windows bitmap format, which was used all the way back in the 80s, one of the original image file formats. If you need compression, but you're willing to give up some of the image data, a lossy image is fine, and you're not worried about transparency, then you want to go for a JPEG. If you need transparency and also lossless, then you'll probably go for like a PNG or a GIF. I know people pronounce that different ways. If you want a lossless image and also no compression, then you might want to go for a TIFF. So that's just some of the considerations you probably want to make when you're choosing a file format for your game images. And also, I'll also talk a little bit later on which image formats are supported by which of the major engines. So that's another thing you got to consider. So file size, made this little simple image in GIMP. It's a 64 by 64 image, which just has like 8 different colors and then a little bit of transparency. You can see the different varying levels of transparency as you go down. And then it also has, so the top colors are increased by hue, which goes from 0 to 360. So I just increased the hue by 30, I believe 30 each time. So it gives you that kind of rainbow color. Now the bottom colors on that image are the exact, like black is 000, blue is 00255, green is 02550. So those are just like the raw RGB values just change. So you got 8 different colors if you change R, G, and B. And I did a talk on color I think earlier, or maybe middle of last year. So go look back on my presentation on color if these terms are unfamiliar, like hue and RGB and things like that. So what I did is I went into GIMP, and GIMP is an image editing tool. You can do a lot of different cool features and editing images. It's free. It's kind of like Photoshop, but it's free, open source. I believe it's open source. So you can download and use it. So what I did is I took this 64 by 64 image and just exported it into a bunch of different image file formats using the default settings. So you can change some of the settings, like I have here, JPEG compression, so you can change compression levels and things like that. But I just used the default settings and listed the different file sizes. So the very smallest one is GIF at 588 bytes for this image. Then a PNG at 711 bytes. Then JPEG's a little bit bigger, and then you got PCX. And then XCF is the standard GIMP format, not supported by many different applications outside of GIMP, but that's like the native format for a GIMP image. Now, when you save, it's going to try to save an image in GIMP. It's going to try to default save it as an XCF. If you want to save it in a different image format, then don't use save. You use export. I know in the old versions of GIMP, I think you actually saved, and then you could pick any of the other formats. But it's export in the latest version of GIMP. And then you have the formats such as TGA and BMP. Those are some of the lossless. I believe TGA is a lossless format. And then finally, TIFF is just huge. And I'll talk a little bit about TIFFs later. Oh yeah, there I have it on the slide there. The top row is hue, added 45 each time for that top row. Okay, so first I'll talk about BMPs. As I mentioned earlier, it's created by Microsoft. I couldn't find a specific like creator of BMP, but I think it's like a part of the very first Windows. I don't know how far Paint goes back. I know it was in Windows 3.0. I don't know if it's in Windows 1 or 2, but I know BMPs were around back when I was using Windows 3.0 and Windows 3.1. I did find online that BMPs were originally released in 1985, as best I could find. So as I mentioned earlier, it's a lossless image and very large file size. And here's a couple of sites which do have some specifications for BMPs. If you go into GIMP and you export as BMPs, then you can have different options for how the bit size for your image. So if you need a much clearer image or much deeper color depth, you can change whether you want the image to be 16-bit, 24, or 32-bit. So let's go here. So this was a cool site I found called File Format. So it does give some information about some of the different file sizes. So since BMP is a proprietary format, then I don't think you're going to find a standard for it, like on Microsoft's site or anything. But this site gives you some good information on, I guess people like reverse engineered the BMP, so it gives you information about how the file's laid out. So I'm not going to do an example of a BMP. I'll go ahead and say I'll do an example of a PNG. I was able to figure that one out. Originally, when I thought about doing this talk, I was like, hey, I'm going to write like an image decoder or a program that will read the image data out of all the different formats, and that was just way too much. So I did PNG, and I'm like, okay, I'm done. So yeah, this site gives a lot of good information about. Then it also has I don't know where this. Yeah, a lot of good information. If you do need to write what they call a decoder, so a program that goes in and reads an image file and displays it to the user, is called a decoder, and a program that takes image data entered by the user or some other location and stores it and writes that image file, that's called an encoder. So decoder and encoder, that's the terminology that I've ran across. Yeah, so there's actually in the Library of Congress, loc.gov, the BMP image file format 5 is defined. So here's so I guess they do have it defined here, but it does have links to other sites. I can't remember if I think this really just points to other sites, but I thought this was neat because it is an official government standard in the Library of Congress they can find here. So it does talk a little bit about the header here, 14-bit header, and all that. So the next file format I'll talk about is GIF. I'm just going to call it GIF, GIF. So GIF stands for Graphics Interchanged Format. This was developed at CompuServe, led by a team by Steve. I think that's supposed to be White. I could be wrong. I'll have to double check that right there. But back in 1987, so I was familiar with GIFs when I was first starting to get on the internet, or probably even before when I was on BBSs in Atlanta. I'd call into dial-up BBS, and there'd be like image files, file shares of images that you could download. So I can't remember exactly where I first saw my first GIF, but I was on both AOL and Prodigy back in the day. I never had CompuServe, but yeah, GIFs were commonly used on the early internet just because of the reduced file size, because people didn't want to transfer full BMP images. And I don't even know if the web browser, so back in the day we had Netscape and Internet Explorer, and I think there was like some proprietary web browsers, like Prodigy had their own web browser and AOL had their own web browser, so they kind of trapped you into using their own web browsers. But I don't think a lot of the web browsers supported like full BMP, so GIF was supported by a lot of the web browsers back in the day. You can go to W3, is it W33 or just W3.org, and get the GIF standard. So here's a specification right here. Copyright by CompuServe, Columbus, Ohio. So I think in here it does have, yeah, so it tells a little bit about the block sizes and all that, which I didn't really research into this much since I did PNG. But if you do want to write a GIF decoder, this is a good resource on w3.org, and it will give you all the information you want to know about GIFs, how they're defined, how they're laid out, and things like that. Here's the information on fileformat.com. That goes into a little bit of the history that I just mentioned. I wonder if this has the guy who led the team. Yeah, so GIF uses LZW compression, which was a patented compression algorithm back in the day, and there's a little bit of history behind that. So I can't remember if they actually started going after people for using GIFs, but everybody got off using GIFs or quit using GIFs because it was a proprietary format, kind of like MP3s and things like that. And they started using PNGs, which I'll talk a lot about in a little bit. So yeah, GIF had a limited, I think the palette size was 256, so you can only have 256 colors. It wasn't limited to like a base 256 colors. You could use any color in the RGB spectrum that you wanted to, but you could only use 256 of those. So it was limited in that respect. Yeah, 256 index colors. One thing that made GIFs nice was you could actually do animations, which if you had a GeoCities page back in the day, GeoCities was a site that offered free web page hosting. I think there were like limits. You couldn't just like upload files. I think they had some like filter or framework that you had to work through. It's kind of like MySpace, but I remember everybody had a GeoCities page back in the day, and you could see a lot of animated GIFs on GeoCities pages. I actually had a GeoCities page. And they had like different neighborhoods. I think they were supposed to be for different groups of free pages. So it was pretty cool. So yeah, GIFs had animations, and GIFs also had transparency. And as I mentioned, the LZW compression. And usually these animated GIFs loop, so they just kept going in loops forever. I think you can still use programs like VDub. That's the one that I use for making sometimes AVIs, and it will actually generate an animated GIF for you if you need to make an animated GIF. Okay, so PNG. This is the one that I really looked into this month. So PNG stands for Portable Network Graphics. I think there was a joke that should be PNG. There was a joke, I think, that originally PNG stood for ping is not GIF, is like a recursive acronym there. So it was developed by the PNG Working Group in 1995. Multiple different standard specifications: RFC 2083, ISO IEC 15948. The one that I've really been looking to is w3.org, and it has the specification here as well. And yeah, this is the one that I use. So this really gets into the technical details of PNGs, how they're laid out. So PNGs use what are called chunks. It has a signature at the top that tells the decoder or encoder that it is a PNG image, and then it has multiple chunks, and these chunks can have different types. So it actually has in here the definition for these chunks. Okay, so here it is. So a chunk starts out with 4 bytes that tells you how long the chunk is, and the chunk can be 0 length, and the length is basically the data for the chunk. So you can have a chunk that has a length, and the next is the chunk type, 4 bytes for a chunk type, and then the CRC, which is cyclic redundancy code, which basically just validates the data in the chunk. So basically the length is just telling you if it has chunk data, how long is that data. So you can actually have a chunk of 0 length. And there's different types of chunks. Like I said earlier, they're all 4 bytes. So there'll be things like IHDR for the header, IDAT for the data in the image, and then finally it ends up with IEND. That's the last chunk. So you'll notice all these chunk names are all capitalized. So one interesting thing that I found out is that if the first character in the chunk name is capitalized, that means that chunk is required by the PNG standard. If it starts out with a lowercase letter, it means it's optional. So I think that I read somewhere that's the 5th byte. So you can actually, I never knew this, but you can like change an uppercase A to a lowercase a by changing the 5th bit So I think in like hexadecimal, well, yeah, if you look at the binary string for that character encoding, the ASCII character value, if you change the 5th bit, that will change it from a lowercase letter to an uppercase letter. So I thought that's pretty interesting. So by looking at that 5th bit, you can determine if that chunk is required or not. Let's go back to our slide. So I'll go ahead and mention that there's also an A ping. So by default, pings are not animated, but there's an A ping that is animated, and it's now supported by major browsers, all major browsers, which I believe is Chrome, Firefox, and Edge. And I think Edge is basically now running on top of Chrome or uses the Chrome back engine. Pretty much the same. So anything supported by Chrome and Firefox, which both support A pings. I don't see a lot of A pings around, but just know that if you do need an animated image, you can use an A ping. And PNGs also use zlib compression. So this is one of those formats where it's lossless, but you still have compression to compress the data. And then there's also this LZ77 compression or format that it uses. I don't know the details on that. So if you're exporting a image into PNG format in GIMP, you have all these different options over here. So when I was testing this, you can unselect certain options such as the color profile, and you can get a significantly smaller file size. So for this test image I had, it was 564 bytes. If I turned off the image color profile, it reduced it down to 93 bytes. So if you're working with really large images, that probably won't make a huge bit of difference. But if you're working with a lot of small images, like little icons, turning that off could save you a lot of file size. And I notice by default, GIMP will export some things like, I'll show it here on the next slide right here. So this is, so I went through and wrote a Ruby program that basically extracts all the bytes out of a PNG image, and that's what you're looking at here. So I'm displaying each byte as by its decimal value because that makes it a little bit easier to look at. So here's the signature. Signature is always 137, 80, 78, 71, 13, 10, 26, and 10. And that's basically just this, I think they said it's like, I forget what the symbol is. But it's a symbol, then the capital letters P and G. And what is kind of neat about this, if you go back to that standard that I was talking about earlier, if you look up signature, PNG signature in the standard, it will have these exact bytes right here. It might be kind of hard to see. Yeah. So right here, it has those same exact numbers, 137, 80, 78, 71, 13, 10, 26, 10. So this standard is really neat because it'll put the exact bytes that you're looking for. So when I started writing this decoder, so the first thing that I did was I wrote out all the bytes as decimal characters to a file. Then I started looking in the standard, in the standard here, and like for iHeader, IHDR chunk, click on iHeader. I started looking for these numbers, these decimal values as bytes in that extract. So then I can start seeing in that file, okay, here's the iHeader, and here's the iDat chunk, and here's the IN chunk. So I started like finding these different values in the chunk or in the file. Then eventually, as I was learning how this file's laid out, I learned how the actual chunks are written out. So you have the signature. Then I learned, it's like, okay, you really need to read these as chunks with the first byte telling you how large the chunk is. So typically your chunk size is going to be 4 for the first byte for the length, 4 for the type, 4 for the CRC, then the length of the data of that chunk. So the smallest chunk size will be 12, 4 times 3. So then when I had my little simple image, so down here in the bottom left corner, I made a simple 1 row by 8 column PNG image, which has the 8 different colors based on RGB values. So you got black, blue, green, cyan, red, magenta, yellow, and white. And if you watched my talk on QBasic, these are the same values, 0, 1, 2, 3, 4, 5, 6, 7, and 8. And that's basically RGB. And if you've ever seen like truth tables, counting 0 to 7 in binary, that's basically what this is doing right here. So B is the first, the rightmost bit, G is the center bit, and R is the left-hand bit. So what I learned is that the second chunk is an ICCP chunk. Like I said earlier, it starts with the lowercase I, which means it's not required. So this whole chunk of length 388 plus 12 is not even needed. So you could actually get rid of this whole chunk right here. And also the next chunk has length 9. It's P, lowercase p, HYS, which I looked it up and it's some sort of like physics type thing. And I really didn't know what they were going for there. And that's, let's see, PHYS. Reduce. So that's one bad thing about committees and standards. You get people that really aren't, they're good at writing standards, but they really don't know technically what they're talking about. So PHYS. Yeah, physical pixel dimensions. So I can just see somebody that isn't a programmer is like, hey, we need to like have this chunk for correlating a pixel to meters. And I guess it could be useful if like you're wanting to take this image and print it out to a poster and this is how big the poster is supposed to be. But otherwise, I don't know why this is useful. And I don't know why by default GIMP exports this PHYS data right here. It's kind of just like useless to me. But it's in there, but you can turn it off in the export settings. I forget which one it is. It's one of these in here. You can actually turn that off. So the next chunk that's in this sample PNG is time. It starts out with a little t, then capital IME. And this chunk tells you the last modification time. There isn't a first modification time, so this will always contain the last modification time. So basically, you can see here, I created this image on April 8th, 2021 at 19:19 in like military time, which is 7:43 p.m., 7:43 and 58 seconds. And oh, by the way, the year is 2 bytes. So what you do, so in my little Ruby program here, I read all the information out, then I displayed it in a human readable form. So you can see in the time chunk right here, I have year, then you have 7 and 229. So what you do is you take 7, since it's the first byte, you multiply it by 256. So it's kind of like when you're reading these bytes, it's like you have 256 to the third is the first byte. If it's a 4-byte string you're reading in, the first byte is 256 to the third, the second bit is 256 to the second, the third bit is 256 to the first, and then the fourth bit is 256 to the 0, which is 1. So basically this is 256 to the first times 7 plus 256 to the 0, which is 1 times 229. So if you take 256 times 7, which I can't remember what that is, add it to 229, then you get 2021. So you're not going to see 2021 in the file there. So that's how you get that value. All the other ones, like month, is 4 for April. And oh, by the way, like January starts on 1. They could have put January started at 0, but then you would have to add 1 to every month. But it just uses the month number that we're accustomed to, along with day. So 1 equals 1, 2 equals 2, 8 equals 8. So yeah, that's the time, which could be useful, I guess. The next chunk in the PNG, this example PNG, is text, lowercase t, capital EX, lowercase t. I don't know why they made the last t lowercase. If there's a reasoning for that or not, I don't know. But basically, this contains the comment. And oh, by the way, when you export a PNG in GIMP, it doesn't give you, like the other options, to put a comment. So by default, it's going to put like created with GIMP. But there is a place in GIMP to actually go in and enter a comment anyway. And so if you need to set that comment value. So to me, it's just like extra data that's really not needed. I guess somebody could like download some images off the internet and then read this value here to see if it was made by GIMP or whatever, if you put a custom comment. I guess you could put your author name, if there's really an image you're proud of, or copyright information in there or something like that. Then the next chunk is the actual data for the PNG. So I was looking through this, and I was looking at this data chunk, and I was trying to figure out how the bytes are laid out. And that's another thing that I wasn't happy about with the standard. They go into a lot of details about the red and the green and the blue channel and the filtering and all that, but they really don't tell you how the pixel data is laid out. It just says it has pixel data. So after I did a lot of research and trial and error, I figured out and it does talk about scan lines in here. So a scan line is one row of pixels in your image. So your scan line starts out with a filter value, which is like 0 through 4. I'll talk about that in a minute. And then triplets for each of your RGB combination. And oh, by the way, in the header, you can actually specify like the color type for your PNG. So with PNGs, you can have either indexed PNGs or like true color PNGs with the RGB values. I didn't look into indexed PNGs, but I think it's kind of like GIFs where you set up this color palette and you draw from those values your color values. So you're just writing out indexes into your palette. I didn't look into that, so I don't know all the details. I did the true color RGBs. And oh, by the way, another color type, instead of RGB, you can do RGBA, and I think that will just put an additional values. Instead of a triplet, you're going to have like a quad, 4 values for every color. So yeah, I just kind of did the simplest possible. So when I was looking at this, I see like 8, 29, 125, 0, 230. Then I start seeing like 255, 1, 0, 0, 0, 0, 0, 255, 0. So when I started seeing these zeros and 255s, I was like, hey, this kind of looks like RGB values right here, triplets. So basically, as I was saying earlier, the scan line is a filter number byte, 1 byte, followed by all your triplets for that scan line. Then it starts again, your filter byte, then all the triplets if you're doing an RGB value. So it's like, this kind of looks like it, but it's like, what's all this 8, 29, 125, and this 74, 17, 6, 255 at the end? So as I was looking into it and looking at the standard, let's see if I can look at the IDAT chunk right here. Or maybe in the filtering. Or no, it's in compression. So then I found out that PNGs are stored in the zlib format, which I didn't know. So this gives you the a little bit of the specification of the zlib format. So this is where it was kind of tricky, because it's like, where does the PNG specification begin and where does the zlib specification begin? So it kind of gives you a little bit of the zlib. So I was kind of confused, because I was like, okay, do I have to extract this information and then send the compressed blocks here to inflate? So with zlib, which uses, I think the algorithm is called deflate, inflate, deflate, which I think is compatible all the way back to, is a standard created a long, long time ago. And apparently the first deflator that was written was PK-zip or PK-unzip, which I used back in the 90s when I remember I bought the Doom Programmer's Guru book, and it came with a CD, and it had a bunch of zips on there. And I was like, how in the world do I extract these zip files? It's back when nobody had ever even heard of a zip file before. So I found out I had to go out and download a program. Or it might have been on the CD called PK-unzip. So PK-zip and unzip were the first program that used this deflate algorithm. But there's been many other apparently programs that implement inflate and deflate, and one is this zlib. So what I found out is what you do is you take that data in the IDAT chunk, and then you just pass that to a program that can deflate that. So interesting enough, let's see here. Here it is, image analyzer right here. There is a Ruby gem zlib that does the deflate and compression for you, inflate and deflate for you, which was pretty nice. So I'll go ahead and talk about the program here. So this basically loads a PNG file. So I created a little class called chunk. So this is going to store the data for a chunk. Now I could put some of the methods actually in here, but I just have the chunk for holding the data. You got load PNG, so that's kind of like the entry point. Down here I just call load PNG. If I was to develop this further, I'd probably have this stir file, the file name passed as a parameter, but I just have it right here where you can turn it on and off based on the comments. So basically this is where we're reading in the contents of the PNG and then printing out the contents. So here's where I printed out as hexadecimal, and you basically take the contents, all the byte data, and call each byte, and then you use this string %02x, and then you do like the little modulo symbol B to change that to a hexadecimal value. So that prints out all your data in hex. To print it out as in decimal, you just take the contents and you call this unpack method, and then you pass it this string in double quotes C star. So that's going to take, for every byte, it's going to take that byte and turn it into an integer value. Then to display that, I'm going to take all those integer values that I'm going to call dot join with the space. So it's going to put spaces between all the different bytes. So here's where I check the signature, that standard signature right there. I created a little function called check sequence, which checks sequence of bytes, which is defined down here. You pass in the sequence, your byte array, and then the index, and it's just going to leap through there and make sure that's a match. And then after that, we're just going to read the chunks. So while I is less than the file size, we're just going to keep running. We're going to load in a chunk, and then we're going to analyze that chunk. And then after we're done with it, then we're going to move like the pointer or the I to the next chunk index. So just to show this off real quick, I have it right here. I'm going to run it again. So you just run Ruby and then image analyzer RB. So here's where I have that right here. It's going to get the total file size 93. Then it's going to display that file in hexadecimal right here. Then it displays it in decimal down here, so you can actually see that 137, 80, 71, 78, 71, 13, 10, 26, 10 right there. And then you can start seeing these chunk values right here. And then let the image data down here. So it's kind of like you're looking into the matrix. Once you know a little bit about how these files are laid out, you can actually start reading these decimal values. And you can actually see them here in hexadecimal as well. But yeah, when it finds, so what this does is when it reads a chunk, it's going to store that in that chunk class, that data structure. Then I'm going to pass that chunk to analyze chunk type. So analyze. So here's where it's reading in the chunk, by the way. So it's basically just going to, it's going to get the first 4 bytes for the length, the second 4 bytes for the type, and then it gets the chunk data based on the length value, and then it gets that cyclic code at the end, which, by the way, I'm not doing anything with that, which really you're supposed to validate your chunk to see if it's valid, which I'm not doing, and I'll show you a side effect of that a little bit later. Well, I'll go ahead and talk about it now. So if you display, when I'm generating one, if you don't check that CRC, it will display it like in the default Windows viewer, but it will not display it in GIMP, which I thought was really interesting. So here's my analyze chunk type. So based on the header value, it's going to check the chunk header type against all these different sequences, which are the same sequences that are defined in this PNG standard. So if I look at PHYS, so here's that physical dimension one, 112, 72, 89, 115. So here it is, 112, 72, 89, 115. So I'm taking these exact decimal values from the standard that's published online and checking against those. So if it matches if the type matches one of these sequence, then we're going to say analyze chunk data, and then I have different functions for analyzing that type. So I have a function for analyzing ICCP, I have a chunk for analyzing IHDR, a type for analyzing TEXT. So let's look at header right here. So if we got a chunk header type, iHeader type, then it's basically just going to read the data out of that chunk. And so for the first 4 bytes is the width, and this is all in the specification. Let's go back and look at iHeader. IHDR. Let's look at iHeader. So here it tells you right here in the specification, width is the first 4 bytes, height is the next 4 bytes, bit depth is a byte, color type is a byte, compression method is type, filter method is a byte, and interlace method is a byte. So you can actually find out like what the different like color. So if you have based on what values in that color byte, this tells you whether it's grayscale, true color, index color, grayscale with alpha, or true color with alpha. So that's what I was kind of printing out here. So here I got color type 2, so I'm going to print out true color. And that's what this like pseudo switch statement is right here. I don't think there's switches in Ruby, so I just had to write this big if, else if statement right here. So if it's color type 0, then it's grayscale, all the values I just mentioned right there. So yeah, I'm also reading like the bit depth and the color type and all that stuff. So that's what's being displayed there. This ICCP, like I said, it's really not even this color profile data. It's not even being used, but I read it in anyway, but I don't do anything with it. So for time, you can see here is where I'm reading in the bits. I could actually get rid of this I0 right here. I started out implementing this one way, and then I changed the way I implemented it. So I really don't even need the I equals 0 now in this. But this is where it's reading the year, those 2 bytes for the year. And you can see where I'm multiplying that by 256 right there. Then it's reading month, day, minute, and second. Here's where it's reading the text. So if you look at the text chunk, so look at TEXT. Now, by the way, there's also iText and ZText. iText, I think, is for international text, and it's defined a little bit differently. And I think ZText may be compressed text. But you can see here 116, 69, 88, 116. So if you look in the switch statement here for text, 116, 69, 88, 116. So it's going to analyze chunk data text. And here in the specification, it tells you the keyword is the first 1 to 79 bytes. And then you have a null separator, which is just a 0, decimal 0. Then the rest of the characters are the remaining bytes. So you know what the remaining bytes are by the length of the keyword plus the null separator, and subtract that from the total length of the chunk specified by the length value. So basically here I have where it says keyword to S. So here we're reading in the data until we get to that null separator. So if data I does not equal 0, then we're going to say, hey, we're done reading the keyword. Or while it doesn't equal 0, read in bytes to the keyword. Then when you get to 0, then you just want to, like I put here, skip the null separator and then read in the rest of the data as actual text. So you can see here when I ran it, actually this took out the text right here. So I think I compressed it or generated this one without the text value. But you can see it actually when I did this right here. Key chunk text, keyword comment, then text is PNG comment. That's what's encoded right here. And then finally we have, so here's where it's getting that physics data, which I don't even use, but go ahead and read it in anyway and print it out if it has it. And finally we get the data. So this is pretty interesting right here. Let's see if I can make this bigger. View, zoom, control num plus. So I used that Reeby zlib gem. So I was actually reading in the bytes here, but I found out I was actually reading in the zlib compressed data. So I was actually trying to read in the compressed data right here. Then I found out, hey, I really don't need to do that. So, where is it at? Okay, so here's all I really need to do. So I have all the data in data, and I can print it out using data pack, then put C star as a string. That'll print out all the decimal data. To uncompress it, I just pass in the data and use pack, so make sure that it's in the byte format. So you just call zlib : inflate dot inflate, then pass in that data right there. Because I think by default it stores that maybe as a string. But you can see here in the output. So here's where I was reading like the zlib compression method 8, and I think you can actually specify in the export settings PNG. I think by default it only, yeah, you have compression level right here for a 9. But if you actually look in IDAT, if you look in the IDAT compression, it actually says in here that it uses 8 for the standard. Like it can support other. It actually has a link to the zlib specification right here, which is kind of neat. So I really didn't want to get into like writing a zlib decompressor compressor. So I was like, okay, I'll just use a gem to do that. But here it is for PNG compression method 0. The zlib compression method flags code shall specify method code 8. So that should always be an 8, deflate compression. And it has stuff about the window size and all that for encoding and zlib and with the LZ77 compressed data. And yeah, I really wasn't interested in like how it's implementing the compression. So thankfully, I just had to call zlib : inflate with capital I dot inflate with lowercase I, then pass in the data, but you got to make sure you call dot pack with C star at the end. So you can see here in the program, here's the data. Here, there's that 8 right there. And so this kind of goes along with what that the standard was saying there with the 8 and 29. So here's the compressed data printed out as a string, so you see all the weird hexadecimal extended ASCII characters. So for like every time it sees a 255, it has this little question mark in a box. Every time it has a 1, you see the little smiley face. So that goes all the way back to like when I was doing QBasic, you could print out a 1 ASCII character, and you'd see the little smiley face on there. So it still continues to print the smiley faces, which I think is cool. So once I pass it to the compression gem, then you get 1 0 0 0. So this is your scan line right here. So it's one scan line. It has by default the 1 compression method. So if you actually go back and look at the standard on on filters, is it filter or compression? Yeah, so here's the different filter types, which I'll talk about in a minute. but you have 0, 1, 2, 3, and 4. Typically, all I've seen is 0, 1, and 2. So 0 is no filtering, 1 is called sub, and 2 is called up. So basically what that's going to do is it's going to take the current byte, or current 3 bytes, and then look, and the next 3 bytes will contain the difference between that byte, or that pixel, and the next pixel, based on the RGB values. Same thing goes for this 2 up, except for it being the byte to the right, then, or the pixel to the right, is going to be the pixel below. So the pixel below is going to be defined as the difference between that value and the value above. But since we only have 1 row of pixels, we're not going to worry about that 2 right now. So this is where I started looking at it. I was like, okay, this actually kind of looks like pixel value here. So I was like, 0, 0, 0. Okay, cool, that's black. Then I looked at 0, 0, 2, 55. Cool, that's blue. Like if you're looking down here at the different values. Then I looked at 0, 2, 55, 1. I was like, okay, what's going on here? This is not cyan. This is not green here. So what is kind of neat what's happening here. So it's going to take the previous pixel, 0, 0, 255, then it's going to add 0, 255, and 1. So if you're familiar with like programming and you've worked with, especially if you worked with NES games like me, you learn that if you take 255 and you add 1 to that, 255 plus 1 does not equal 256. 255 plus 1 equals 0. So that gives you 0, 255, 0, which is green, which I think is actually pretty cool. But when I wrote my encoder, I just used a 0, but for the scan, the filtering type. But if you have 1 as the filtering type, then you basically just add 1 to the previous pixel. So now we got green, 0, 255, 0. And I actually have this on the next. This is a little bit better explanation right here. I'll walk through this and put it all out. So here's that same scan line that I was just looking at in the screen. So it's 1, 0, 0, 0, 0, 0, 255, which is blue. Then 0, 255, 1, which you add that to the previous one. Then you get 0, 255, 0, which I have like right here. 0, 255, 0, which is your green pixel. So to get from green to cyan, which is 0, 255, 0, you just add 0, 0, 255. And that gives you cyan. No red, all green, all blue. So to get from cyan to red, then we need to set the G and B back to 0, and we need to set red to 255. So what do we add to 0, 255, 255? We add 255, 1, 1. So you're going to add 255 to 0 for the red, and then you're going to add 1 to the green and 1 to the blue. So that's going to roll over both the green and the blue, which gives you just 255, 0, 0, which is what we got right here. So to get from red to magenta, so magenta is all R, no G, all blue. So to get from 255, 0, 0 to magenta, we just add 0, 0, 255, which gives us 255, 0, 255. So if you look at it right here, I have it all laid out. These are the values that appear in the scan line, and these are the actual pixel values over here on the right. So to get from magenta, which is all red, no green, all blue, to yellow, which is all red, all green, and no blue, we add 0, 255, 1. So that will add 255 to the green. So then we have 255, 255. Then we're going to roll the blue back over to 0. So to get from yellow, which is all red, all green, and no blue, to white, which is all red, all green, all blue, we just need to add 255 to the blue value. That's what I'm doing there. So that's how you get from a uncompressed scan line to actual pixel values in RGB. And you can look at the uncompressed data there. So it's just basically the smiley faces and the question marks. So I went in and did, to make sure I understood this, I did a lot more examples. So if you have a 2x2 red square as a PNG in RGB format, and you export that in GIMP, then what you're going to get is 1, which is the scan line, which means the scan type, which means it's using that sub. So the first pixel is going to be 255,200 for red. So to get from the first red pixel to the second red pixel, we're just going to add 000 because there's no change. So you'll see 255, 255,000, 000. Then we're going to go to the next scan line and determine how long a scan line is by the value that's specified in that header chunk, IHDR chunk. That's how you know how long the scan line is. So in the second scan line, when I exported this with GIMP, it put a 2 for the filtering type. And that means look at the pixel above. So for the lower left corner pixel, it just has 000, which means look at the pixel above. It's red. 000, this one's going to be red too. Then for the lower right hand corner, same thing. It's going to say, hey, look at the pixel above. It's red. 000, this one's also red. Also did an example with cyan. So it's the same thing. One for the scan line type, but it's 0, 255, 255. And then it's just the rest zeros because it's going to look at the pixel to the left for the first scan line. Second scan line is going to look at the pixel above. White's the same thing. Okay, so here's a black and white checker right here. So the first row is black, white. Then the second row is white, black. So it actually uses the filtering type 0 for both lines. So this says these are just the pixel values right here. So the first pixel is 000, the second pixel is 255, 255. Then on the next line it's 255, 255, 255, and 000. That's as simple as it can get. Then I did a 2x2 pixel, 2x2 image with red, then yellow for the first line, then green and blue for the second line. So first line is using the sub filtering type, that 1. So it's going to be 255,000 for red, and then for yellow it's going to be 0. So it's going to use the previous 255 red value, then 255,000, which gives you 255, 255,000. Then for the second line, it's going to use 0 filtering type, which means none. And then so it's going to be 0, 255, all red, no red, all green, no blue. Then 0, 255, no blue, no red, no green, all blue. So then I went in and it's like, okay, what if I did a 1x4 image, PNG image? So what I got was, and it's all blue. So I got 0 for no subtype, 0, 255, which is blue. Then all the remaining lines are 2, which means look at the pixel above, then 0, 0. So it's basically just going to copy that blue value down to all the other pixels in that 1x4. If you do a 4x1 blue, then it's going to use the 1 subtype, or the 1 filtering type, which is substitution. Means look at the pixel to the left. So you got 0, 255, which is blue. Then all the rest are going to be 0. So it's just going to keep referring back to the previous pixel. Then I went in and did a 1x4 red, orange, yellow, and this kind of lime green. It isn't pure green. It's kind of like halfway between yellow and green. So the first line is 0, then 255,000 for red. Then for the second line, it's going to use the 2 filtering type. Look at the pixel above. So the pixel above is 255,000, which is red. So we want to add to that 0, no red, 128, half green, and 0, no blue. So that's going to give us 255, 128, 0, which is orange. Then for the next line, we're going to have 0, no filtering. So it's just going to be 255, 255, 0 for yellow. And then the final line is the filtering type 2, which means look at the pixel above and add this to it. 129.00. So we start out with 255, 255.0, and for the red value, we're going to add 129. So what that's going to do, you're going to add 1 to roll it over back to 0. Then we're going to add 128. So that's going to end up with 128, 255.0. So 255 plus 129 equals 128. It doesn't sound like a logical mathematical equation. It's kind of like 2 plus 2 equals 5, but 255 plus 129 equals 128 when you're rolling over with that 8-bit byte. So finally I did a 4x1, red, orange, yellow, and that lime green. So it writes it all out in all one scan line, 0 as the substitution type. So this is just writing the raw RGB values. 255.00 for red, 255.128.0 for orange, 255.0 for yellow, and then 128.255.0 for that lime green. So I think that's about it for PNG. So that was the one that I really looked at in depth. So after I did that, just like yesterday, I went in and was like, okay, I decompressed a PNG file. I wrote a decoder for PNG. Can I write an encoder for PNG as well? So that's what I worked on. It's a little bit simpler. It took a little while to figure it out. It took a little while to figure out how to write these stupid bytes to a file, because if you ever try to write just like I believe a 10, which is new line. So as I mentioned in a previous talk, you got a line feed and a carriage return, and in Windows, if you write a new line, then it tries to put both a line feed and a carriage return, a 13 and a 10. So what you got to do is when you open your file for writing, you got to open it in WB format. So it means open it in write format with binary. So that will use like the Unix style line. And otherwise, you're going to get extra 13s and 10s in here, which is annoying. So basically, I'm still using my same chunk data type class, and I just have a method for each of the chunk types that I'm writing. One for creating an iHeader chunk, one for creating an IDAT chunk, and one for creating an IN chunk. So here's the create iHeader. I'm basically just going to write 8 for the width, 8 for the height, 8 for the bit depth, and 2 for the color type. That's the data for the chunk. And here's the by the way, here's the header right here, which is in the standard. The length is just going to be how many bytes are here, 13 bytes. And the CRC, I'm just writing a 0, which is bad. So if I work on this a little bit more, I really need to go in and figure out how to do the CRC check, which is actually defined in that standard. I just didn't take the time to do it. CRC right here. It actually has the cyclic redundancy code algorithm. So yeah, I just didn't feel like looking at this right now, but it's got something to do with X and powers, and I don't know. I didn't take the time to look at it. So that's the header. So we write the signature, that standard signature, write that to the file. Then we write the header chunk, and then the data chunk is this right here. So I created a, how many is this? 1, 2, 3, 4, 5. I created an 8x8 pixel image right here. So you can see I have so I'm using 0 as the filtering type for each line. I think some of these split across lines. Yeah, each one of these is each 2 lines here is actually only 1 line, which you can see by the line numbers on the side. So I'm writing 0 for no filtering, 255.00, 255.00, 255.00. So this is all red, and when it starts going over to 255, 255.0, this is the yellow. So the first 4 scan lines are going to be red and yellow. Then the last 4 lines are going to be blue and green. So I'm going to take all that. So all that data is in a data array, just as decimal values. And I can print that out by doing data.join and then passing in a white space. So that's going to print out all the numeric values right there. So to actually deflate this, so deflate is basically compressing. So to deflate this, we're going to call zlib : deflate with a capital D : deflate. Then we're going to call data.pack C star. So that means to take all those integer values and convert that integer array into a byte string using the 1 byte for each integer. If you don't do this pack, then it will try to compress a string of this exact array. So you'll start seeing, like, it will try to compress open square bracket 0. So you'll start seeing like the 32s for the spaces, and you'll see the values for the commas, and a value for the 2 and a value for the 5. So it's going to take each one of these. If you convert this to a string, it's going to take each value in here and try to compress that. And that's not what you want. You want the byte data. So that's what this data pack does. It takes that integer array and convert it into bytes. Now, I forget what the 8 right here does. I think you got to pass the 8, which means 8 bits, I believe. So, yeah, that's your chunk data right there. So then we're going to put that data into the data type right there. Then we're going to set the length to the chunk data. So this only works up to 256. I didn't calculate the values over because I'm just doing an 8 by 8. And again, I'm not checking the CRC, which is bad. Then the final right here, we're going to create an in chunk. So here's the IN. There's the type, which is characters I, E, N, D. This is in the standard. There's no data for this chunk. The length is 0 because there's no data. And we're not doing the CRC, which is bad, as I mentioned before. So what's interesting about this, so this is going to generate a file called myPNG. Let's see here. Do I have my... So I'm going to delete my PNG. Then I'm going to run Ruby image generator. And by the way, I'll put this out on GitHub probably. On my GitHub so people can view the code. So here we go. So there's that huge honker array that I mentioned with the red, yellow, green, and blue values. So here now here's the pack data. So like I said, every 0 is just a space, and every 255 is a question mark with a box around it. So once we compress that data, we get this string right here. And then compressed data in depth, which I'm kind of surprised this doesn't have the 8, so maybe I'm not using the exact right compression. But if you go, look, dir, you can see here's my PNG. So it generated the ping. And then if you go into the presentations, image file formats, image analyzer, there's my PNG right there. I was shocked when it actually worked. Double click on it, and if you zoom in, there it is. It's still kind of hard to see. Red, yellow, green. 8 by 8 PNG. So, oh, by the way, GIMP is kind of slow here. Let's start GIMP. Actually, that's pretty fast compared to how long it usually takes. So if we go into GIMP, and we do File, Open, image analyzer, or image file formats, image analyzer. So if we try to open up the ping here, it's going to give us an error. And it's going to say error while reading D, file corrupted. I'm thinking this is because I didn't do those CRC checks. I'm kind of surprised that GIMP just didn't say, hey, file's corrupted, then load it anyway. GIMP just says, no, file corrupted, we're not reading it. But in the default Windows viewer, I guess it doesn't do the CRC checks, so you can actually see it in here. So that's on my to-do list. Go back and figure out how to do those CRC checks. With doing a talk every month, it's hard to get in too far into the details. But like I said, I wanted this talk to be the different file formats, but I still wanted to be a little bit technical, a little bit programming. So that's the programming portion of this talk. Back to file formats. So the next one on the list is JPEGs. Stands for Joint Photographic Expert Script, developed in 1999. 1992 by a Joint Photographic Experts Group Committee. It uses that lossy compression. And oh, by the way, there is a specification for this, which I think I put at the end. Or you can go to jpeg.org. jpeg.org is apparently the official site for JPEGs. And you click on JPEG. And I was like, hey, I want to find the JPEG standard just like the PNG standard. So it's like, oh, documentation. Where is it at? Okay, not that one. Works plan spec. Work plan. Actually, I think I have it at the end of the presentation here. Maybe I don't have it on here. Yeah, where'd I have it? Anyway, if you find requirements and guidelines, is it right here? I don't know if this is it. Okay, here it is. So, okay, here's the JPEG standard. Cool. Here's the standard right here. Oh, it's CHF 198. Then I'm like, what in the world is CHF 198? So then I like went to DuckDuckGo, did CHF 198, and oh, I got to pay 198 Swiss francs for the JPEG standard. I was like, really? That's equivalent to 214 US dollars, $214.59. I was like, that's a real bummer. I understand these guys got to make money, but boy, $200 for a standard, that's kind of pricey there. I'm sure if you look around, you could probably find it elsewhere, but yeah, I don't know. Yeah, so the JPEG standard is ISO IEC 109.18. Cost about $200 if you want to download it. So yeah, in JPEGs you have different quality settings from 0 to 100, I think, or 0 to 99. You can actually set that in your GIMP output. And you can put a comment. So with JPEG, you can put the comment right here. But in pings, you got to go into that other option to set that. There's some other options, subsampling, DCT. I didn't look into it that far. I just know it's like, hey, if you want a compressed image, you're not worried about transparency, use JPEG. Especially if it's like a really big image, go with JPEG. So I did do a little bit of analysis. So I took this picture. It's 1024 by 768. And then I exported this in JPEG for 4 different quality settings. So the first one I did quality 90. And that generated a file size of 472 kilobytes. If I reduced it to quality 60, then it reduced the file size down to 227 kilobytes. So that's like half the size. And you don't lose very much quality at all. So then down here at the bottom, I did the comparison with the zoom set to 400. Same image, same exact image. I just zoomed in 4 times or 400%. There's not very much loss in quality from quality 90 to quality 60. Now, if you go from quality 60 to quality 30, then it reduces the file size down to 138 kilobytes. So it's almost like reducing it in half again. Still, you're not losing too much quality if you look at the whole image. But if you look at the image, you start seeing a little bit more pixelation and blurring if you zoom into 400%. Then if you reduce the quality down to 0, then it reduces the file size all the way down to 19 kilobytes. But you notice a lot of like reduced number of colors and pixelation in the big image. It kind of looks like an old like CD-ROM game here. And then if you look at the zoomed in 400 times, then you just can't make out anything at all. It's just all pixelated and everything. So where this could be important is if you're doing a JPEG image as a texture. And if you like get really close up to a wall, then you'll start noticing this pixelation effect right here. So if you like do it all the way down to quality 0, then you're going to really have some really horrible looking walls if you get really close. So I'm just going to mention SVG, scalable vector graphics. I don't know a lot of engines that use SVGs. I think Adobe Flash Animations, I don't know if they use the SVG format or just something like it. but and also was the Microsoft equivalent Silverlight. It may use like an SVG type image. If you want to export SVGs, I recommend Inkscape. It's a free open source type program that you can use to generate SVGs. It's developed by the W3C Worldwide Web Consortium in 2001. I don't know if a web browser will display an SVG. I think it will, because I think I've seen like on some sites, some encyclopedia style sites use SVGs. It uses vector graphics, so it's lossless. One nice thing about SVGs is like if you zoom way into the image, it's still going to look crisp because it's just defining like circles and rectangles and triangles and lines. And here's the specification for SVGs right here, by the way. So it probably wouldn't be too hard to write a SVG decoder. I think this specification is free. I don't see where you download it. Yeah, I'm not really concerned about SVGs because a lot of engines don't support SVG by default. So another one, oh by the way, TIFF. It's another really old file format, tagged image file format, developed by Aldus Corporation in 1986, which I think it's owned by Adobe now. The first time I was going to find my old scanner. First time I ran into TIFF was when I bought my old scanner for my 386. It was like a hand-drawn scanner. I'm going to have to find it and take a picture and put it up. But basically, you drug the scanner down. You can hold it in your hand, kind of like a mouse, and you drug it down half the page, and then you would drag it down the other half of the page. Then the program would take like 30 minutes to piece in the two sides of the image together to give you your scanned image. So that was like the home consumer scanner back in the mid-90s. Now, they had like flatbed scanners, but these days you just go buy a printer with flatbed scanner built into it. I don't think there's still any hand-drawn scanner or hand-pull scanners anymore. So if you're interested in, oh yeah, by the way, TIFF, the actual standard specification is on the Adobe site, adobe.io. Yeah, specifications for TIFF. Open source. Back in 1992. So that's pretty cool. You can actually go in and it has the entire standard on here. But yeah, if you got a lot of free time on your hands and you could read this, and it also uses LZW. So by the way, if I didn't mention it earlier, the LZW compression method was patented. I can't remember who owns the patent. But I think it got to the point where patents are only good for 20 or 21 years. I remember I took a computer law class at Georgia Tech, and I think it's like 21 years that a patent is good for. Then they didn't re-up the patent. So I think LZW is back like in the public domain now. But yeah, if you want to learn about TIFFs, here's the document for you right there. It's like, how many pages is that? 121 pages of TIFF specifications. So TGAs, I forgot where I first ran into TGAs. I think like Allegro, yeah, Allegro 4. Allegro uses TGAs. TGA stands for Targa or True Vision TGAs, created by AT&T Epic Center / True Vision in 1984. I don't think I had a formal specification for this, but the file format size had a specification for TGA. So I'm just saying, hey, TGA, be aware of it. So I read on a couple of forums, some people really like using TGA for one reason or another. It may be more simple to parse, or maybe, I don't know. I can't say what the pros and cons of TGA are, but it's used for textures. You can specify RLE compression in the origin. So another one, PCX, Picture Exchange, created by Zsoft in 1985. The only reason I know about this is it was also supported by Allegro 4. I remember back in the day I used I think it's JASC Paint Shop Pro. So it was like the free shareware version of Photoshop. So if you're a poor like me back in the day, then you just go out and download JASC Paint Shop Pro off the AOL forums or off the internet somewhere. And it had like a limited time trial, 30 days you could use it. So here's another format, HEIC. So this is a newer format, high efficiency image file format, created by the Movie and Picture Experts Group in 2015. HEICs for high efficiency video coding. So the first time I saw HEIC was recently when I went out and took some pictures for textures using the iPhone. And when I went to copy my images off to my hard drive, my desktop, using a USB cable, I was like, hey, where are the JPEGs? I was like, oh, they're HEICs now. So this is apparently the new standard that Apple is using, at least on their mobile devices, for storing images. So I'm just saying, hey, be aware of HEICs if you're taking pictures. And by the way, GIMP will consume or load an HEIC file, but you'll probably want to convert your HEIC to a format such as JPEG, which is supported by game development environments. And here's another one I found out recently, WebPs. I've been familiar with WebMs. I like WebMs. I'm using WebMs on my own site whenever I post a game and on my own site, and I want to do an image or a video embed of the game. I use FFmpeg to convert like an MP4 into a WebM, and then I reduced the resolution to like by 600 by 360, 16 by 9. And then I just put that WebM directly. I'm running WordPress, so I just put that load that WebM as a media file and just paste it in using the media paster thing, media loader, and it works great on desktop web browsers, on Google tablets, Android tablets. Only downside is it doesn't work on Apple devices, so really you might want to put an alternative in there if you're using a WebM. So anyway, this isn't a talk about WebMs. The point being that WebP is kind of analogous to a WebM, where WebM is for movies, WebP is for images. I've seen where WebP is now being used on YouTube, I believe, for like thumbnails and things like that. So it seems like it's being used a little bit more. It is a standard created by Google, so if you want to look at the standard, it's here, which explains why it's used on YouTube, because YouTube is owned by Google. So here's the standard. It actually has some encoder and decoder tools here. But I don't see, I didn't get into looking at this because most game engines, I don't think any game engine support WebPs. I'm just mentioning WebPs because, hey, it may be a new format. Yeah, so it supports both lossless and lossy. It supports transparency and animations. So those are all the image file formats I'm going to talk about. I'm sure there's millions of others out there, not millions, but there's probably tens or hundreds of other file formats. I don't know, of varying adoption. So I mentioned this a little bit earlier, but if you're creating bitmap images, GIMP is a good tool. It's free and open source. Another good one is this Aspirite. I think it costs like $15 or $20, but you can generate BMPs, FLCs, FLIs, GIFs, ICO is an image or icon format for Windows, JPEGs, PCX, PCC, PNG, SVG, TGA, and WebP. And also, you can just use old-fashioned Paint. While Paint's still supported by Windows, I think Paint's getting taken out of Windows and you have to download it through Microsoft Store or something like that. I don't know. But Paint does BMPs, JPEGs, GIFs, TIFFs, and PNGs. Previously, it only did BMPs, but in later versions of Paint, it started supporting these other formats. If you're doing vector graphics, as I mentioned earlier, Inkscape's the way to go. I mean, it takes a little while to figure out, but it's a good tool. Okay, so I went through... I went through 4 game development engines. Unity, Unreal Engine, Godot, and GameMaker, and I tested or made a listing of each of the file formats that each of these engines support. So Unity supports, so the formats that I'm looking at are BMP, GIF, JPEG, PCX, PNG, TGAs, and TIFFs. So Unity supports all of those except for PCX. It does not do PCXs. Unreal Engine, it does all of those except for GIFs. Unreal Engine will not do a GIF, where Unity will. Godot, you kind of think Godot is kind of like an open source. I don't know if it's GNU, but GNU MIT license style. And I don't know what the engine is. I don't know what technically the license is for Godot, but I'm sure it's one of the two, probably MIT or GNU. I know a lot of people didn't like GNU 3 or GPL 3. I meant GPL, not GNU. So it's not going to support some of those proprietary formats. So Godot does not support GIFs, it does not support PCX, and it does not support TIFFs, but it does support TGAs, PNGs, JPEGs, and BMPs. And GameMaker supports all of those except for PCX and TGA. So you can look at this both ways. So I was going like down the columns. So if I had like, I don't know, some PCX files and I didn't want to convert them, then I could use Unreal Engine. Or if I have TIFFs, then I can use everything except for Godot. Or if I have GIFs, I could use Unity or GameMaker, but I couldn't use Unreal Engine or Godot. But converting your images to another format wouldn't be too difficult. I mean, you could do that with a script, but that's extra work. It's like, hey, if I just have some JPEG supported by everything, but say, hey, I have some PCX images, I don't feel like converting them, then you can use Unreal Engine. Or if you have BMPs, that's supported by all. Or if you have TGAs, you can use Unity, Unreal Engine, Godot, but not GameMaker. Oh, and by the way, when I was doing these image file formats, your TIFFs have to only have one F in the extension to be imported into Unreal Engine. So yeah, here's where I just kind of pulled the supported file formats off. Like I pulled this one off the Unity website. Like I don't even know what an HDR is. I saw PSD quite a bit. I think PSD may be the Photoshop or Paint Shop. I'm not sure. I don't know what a PICT is. PICT. I pulled this Unreal Engine off the like load texture for textures, load texture drop down list. Some of these have like HDR. I don't know what an HDR. It has an extension of EXR. I don't know what a DDS is. Godot has some additional formats like curve text, atlas text. I don't know what DDS is, but it also has like the EXR and HDR, PVR, and all sorts of other bizarre formats. It also supports WebP. And then GameMaker, it supports PNG, GIF, JPEG, TIFF, HEIC, BMP, something 2BP. And I don't know about this MDI. I thought MDI was MIDI, but I don't know. Maybe, yeah, for an image file. MIDIs are for music. So anyway, that's it. There's the references. So I'll put the code out for my decoder encoder for pings out there for anyone who wants to take a look at it. Oh, by the way, go to knoxgamedesign.org for all the latest talks and presentations and upcoming events. By the way, I've been saying by the way quite a bit. ldjam.com. Ludum Dare 48 starts in a week, so yeah, it might be just a small get-together or something. I don't know. I posted something on the Discord to see if anybody would be interested in getting together, and I haven't heard much back yet, but yeah, may have a small gathering. I don't know, but anyway, yeah, Ludum Dare 48. So it's Ludum Dare, the 48th Ludum Dare. It used to be called LD48 because it typically was done in 48 hours. So now we're at LD48. So one of the things they said is like, oh, it'd be nice if everybody did a 48-hour compo entry. It's like you don't have to, but kind of like in the spirit of 48. I thought that was cool. But yeah, theme slot around, so I think the voting will start probably next Monday for themes. So anyway, yeah, check out if you want to contact us. There's the link to the Discord right here. Go there. Join us on Discord. Also updated the directory, so I took out all the handles. Like I just didn't even want to deal with social media. So it's like you got a website, we'll put the website up here. We'll link to it. So some of these like websites didn't work anymore, so you can't click on those. But I still wanted to have the website name just for archival purposes. And that's about it. Pull camera. Okay, so appreciate everyone listening and watching. That's Knox Game Design for April 2021. Next month will probably be like show off. I don't know if anybody's going to be doing Ludum Dare. It might just me showing off my one game. Seems like there hasn't been a lot of interesting game development lately, and I've gotten kind of burnt out too. I didn't go over. Yeah, let's go over to the Discord. Let's go back. See if we've got Discord up here. Where's Discord? I don't see it. There it is. So, one new thing, we added a game dev resources channel. So, anybody that has resources. So, like somebody's looking, Mythic, M-Y-T-H-I-K, he did some C++ programming. Now he's kind of looking into Unity, so I linked him a talk that was done back in 2019 for Knox Game Design. So if you have resources, you can post them here. But as like all these forums, we post things and we kind of get off on tangents. So we try to keep the tangents in general, but sometimes we get, yeah. And I posted a wall of text right there. It's like, hey, by the way, here's all the gotchas for Unity right here. I need to reformat this or something, but because some people were posting like tutorials here in general, and which is fine. I don't care. Yeah, so Mythic, yeah, I don't think he did that one. So game show off. So I made a new release, or first release, I guess, of the GameMaker game. So you can click here, play online. It's kind of like Sorry. A lot like Sorry. Just more options. Yeah, so that's it right there. So you got different colors you can choose, and different pieces you can use. Like I got the jacks here, and nuts and bolts, and then there's a button too, things like that. So if you want to play it, you can now play it in a web browser. You can also click. Now here's where I got a WebM embedded right there. So you can just click it right there, and it just runs right there. And no YouTube, Rumble, BitChute or anything involved. Just paste it. And it's pretty small too, like a few megabytes. So you can download it on itch.io. You can download it on GameJolt. There's no leaderboards or anything integrated into this. Just kind of like, hey, I want to make a Sorry game. I got a couple of ideas for other games, but I'm kind of burnt out on making games. I guess that's kind of my point. I got off on a tangent of showing this off, but yeah, I've been working on this since like February, and it's April now. I did Disconnect back in January. Then before that was Polyglot Penguin back in December 2020. So I was doing a game a month, but like, I'm getting too old. It's like I don't have all the time in the world anymore. It's good to get outside and do stuff instead of just sitting inside making games. So yeah, here's Mythic Frank Hale. So he has Roguely. So I'll post it. I'll post this video on the monthly notes and put in the link as well. So I tried playing this. I need to get back to it again, but I think it requires Lua. So I downloaded the project files. I don't know how loud that is. But it looks really good, like a little dungeon crawler. He has little @ symbols, kind of like Hexadecimal, or kind of like ANSI style graphics, but he has, I don't know, some cool pixel-based graphics too. A lot of little critters, coins you can pick up, you can attack the little critters. So it's looking really good. I like it. I just need to try running it again. I think he actually put out instructions on how to do the Lua integration. I think he's using Lua scripting as the back end, which I've done Lua before. I just couldn't get it to compile with this at the time. But I think he worked out the bugs, and I just need to try it again. Yeah, I pasted my GoMinasci. Not much else going on. Yeah, Mythic's been really busy with this one. Kind of wish it was just like an executable that could just run. So I kind of feel, I know what other people feel like when I put out my Pygame game. I was like, okay, here's the files. I was like, okay, can I just have an executable? But yeah, he wrote instructions on how to install and run it. So I think that's the only game development that's been going on over the past month or so. A lot of chat going on, things like that. Anyway, that's going to wrap it up for Knox Game Design, April 2021. See everyone back in a month.